Hello, this is Mr. Flatness, and today we're going to be working with the concept of problem solving. There are many concepts to be learned in mathematics, and problem solving is a way for us to take all those concepts and apply them to the real world setting. So, it's good to have some type of process or a strategy that you can use to solve problems effectively. In this example, we have a training program that swimmers use to be more effective in their races and to get better and improve. Our job is to determine how to solve this problem effectively using many different types of strategies. To start, I'll go through all the different steps necessary to solve problems effectively. It's important that you write these steps down in your notes. We'll be taking notes all throughout the year, and for you to write down the notes in your notebook is very important. Especially neatly so that you can understand them. You can utilize the pause feature at any time, pause the slide in my voice, write down all the things you need to write down, and then you can press play and then listen as I go through each problem. So, step one, we're going to read and understand the problem. So looking at this, I am looking for, first of all, facts. Are there specific facts that are going to help me solve this problem? I'm also going to be looking for what is it that I need to find out. And finally, I'm looking for keywords. And keywords tell me a lot about the operations that I might use, add, subtract, multiply, or divide in any particular problem. So let's begin. Your swimming coach plans the number of meters you will swim in each practice. The number of meters for each of the first 7 practices are 1,000, 1,250, 1,000, 1,500, 1,000, 1,750, 1,000. How many meters would you expect to swim in the 8th practice? Important facts that I see immediately. I see that there are 7 practices that have been planned where we have increments that go up and then go back to 1,000. So if I look at every other number, we have 1,000. And then also I notice that I have distances that increase. So there's 7 practices. I also want to look and identify what do I want to find out. I want to know how far am I going to swim on the 8th practice. So those are important facts that I can use in the next step. Step 2, I'm going to make a plan. How am I going to solve this problem? Well, here are some things to write down that you can use. These are all effective strategies that you can utilize to solve a problem. You may not use every single one, and also some of them may not work for every single type of problem, but here is a list that you can use. So, we can do anything from making models and pictures, to even acting it out, to guess and check, and then go back and readjust. Look for patterns. We can make lists or tables. All these things we can use. And again, also looking for those key words that can help me in knowing, am I going to add, am I going to subtract, multiply, or divide. Step 3, I'm going to solve the problem using my plan. So looking through all of this, the facts, finding out the question, I'm going to see if I can try to find a pattern, because as I look through these numbers, 1,000, 1,250, 1,000, I see that there's a pattern that emerges. So the best way for me to look at patterns is to write them down in a table. So I see 2 things happening. I'm talking about the practice and I'm talking about a distance. So I'm going to use a table to try to find a pattern. So in practice number 1, notice we swim 1,000 meters. So I'm going to put in here 1,000. And then in practice 2, we swim 1,250. So I'll just continue with the practices. Practice 3, we're going to go with 1,000 again. Practice 4. Now we're at 1500. Practice 5. We're back to 1000. Practice 6. We're at 1750. Practice 7. We're back to 1000 again. So those are 7 practices. So let's look for those patterns, or a pattern, if we can find one. Well, the first pattern I see is that on the odd days, day 1, 3, 5, and 7, I notice that the distance is always the same, 1,000 meters. So then I'm going to look at the even number of days, day 2, day 4, day 6. And here's where I see the numbers 1,250, 1,500, 1,750. So what I see there is the numbers getting bigger. So, looking at this, I'm going to shrink that down so I can have a little more space to write. I'm going to see if there's any difference there. So 1,250, then it goes to 1,500, and then it goes to 1,750. So the distances increase. So the first thing I think I'm going to try to do is see, is that distance the same between each day? So in order to find that, to find out how much it increases by, I can use subtraction to find out the difference between 1,250 and 1,500. So I'll subtract the two. And when I do that, I get 250 meters there, and then I notice that if I add 250 meters to 1,500, I get 1,750. So now I have found the pattern. Each time that I move to a different practice, I'm going to add 250 meters to the previous practice. So to find practice number 8, I just need to take 1,750 and add 250 to it. So 1,750 plus 250 would be 2,000. So my answer for practice number 8 would be 2,000 meters. Step 4. Check your answer. A lot of times when students solve problems, the moment they write down the answer, they think they're done, and they don't go back and do the most critical step, and that is check to make sure that your answer makes sense. This can save a lot of very common mistakes that some people might call them silly mistakes, because at times students and teachers go too fast, and their answer, if they would look at it and then go back to the question, they could double check to make sure they didn't make an error like that. So we said that in practice number 8, our answer was 2,000 meters. So looking back, does this answer that we have fit the facts of the question? And looking at it, it does. I know that my distance is in meters. I know that it is an answer that makes sense, because as I move to each different practice, I know that the numbers are getting bigger, especially on the even number days. So I know that my answer has to be bigger than 1,750. So, and it does fit a pattern that increases by 250 each time. The only thing we didn't talk about is an estimation. And before we solved the problem, we could have looked at, as the numbers go up, we could notice and make a reasonable estimate to know that, that the answer that we come up with must be bigger than 1,750. So, looking at the critical step 4 here, looking at our answer, we know that it fits the facts. We know that it definitely makes sense, so that we can say with a lot of confidence that 2,000 meters is the correct answer. This next slide, I have many different words that are keywords that would help you know what operation to use when solving a problem. So I would press pause and write all of these, or actually just write this table in your notes, and this would be a table you could use all year long. Talking about all the important words that would mean the same thing as adding, the words that mean subtract, multiply, and divide. So take some time, write these down, and definitely circle it. Somehow write this where you know where you can always find it. Go back to it, tab it in your notes, whatever, because you'll be using these words all year long. Here's a problem for you to try. A good strategy would be to press pause right now, try to solve it, and then once you're done solving it, press play, and then watch me solve it and see if you're on the right track. Again, I want to use the 4 steps necessary to solve problems effectively. So step 1, we're going to read to understand. Pete wants to buy 2 pairs of jeans for $34.99 each, and 3 t-shirts for $19.99 each. If Pete can spend $100 total, does he have enough money? So what are the facts and what do I need to know? I know that Pete needs to buy 2 pairs of jeans for $34.99 each, and he needs to buy 3 t-shirts for $19.99 each. The other thing I know is that he can only spend $100. So, taking a look at this, I can use estimation to solve this problem without necessarily having to solve it exactly, to see if I can come up with the answer that way first. And then I can also refer back to my table where I had all the important words. I see the word each. And if you went back and looked at your table, you would notice that the word each implies multiply, or it could imply divide. But taking a look at this, if I wanted to solve, I know that I need 2 pairs of jeans. So pair 1 is going to be $34.99 and pair 2 is also going to be $34.99. Well, I'm going to take a look at that, and I'm just going to round up and estimate first. So, because in money, if I round up, then I'm going to be over what the actual price is. And if I have more money here than the overestimated answer, then I'm going to have enough money. So I can really just estimate here and solve. So $34.99, I'm going to look at that as $35. So pair 1 is going to cost $35. So is pair 2. Okay, so that's talking about the jeans. And then I'm going to look at the t-shirts. And so $19.99 each, I'm going to turn that into $20. So the first t-shirt is $20, the second t-shirt is $20, and the third t-shirt is $20. So we could either add the numbers up, or now I can know what the word each means, because 35 plus 35 is the exact same thing as saying 35 times 2. 20 plus 20 plus 20 is the same thing as saying 20 times 3. So multiplying this out, 35 times 2 is 70. So the jeans are going to cost me $70. And the t-shirts, 20 times 3 is 60. So I would add the cost of the jeans to the cost of the t-shirts to see how much total I would need. $70 plus $60 is going to give me $130. So now I need to check and look at my answer. Okay, we came up with $130 of overestimation. I've checked through my work to make sure that I didn't make any errors there, and it all looks good. So $130 is more than $100. So when I estimated, I know that the jeans and the t-shirts cost more than what I have. But I also need to go and take a look at, how by me overestimating, did I overestimate too much? So looking at this, on the jeans, I only rounded up a penny each time. So on the jeans, I was only over by 2 cents. 1 penny for each pair. For the t-shirts, again, I rounded up by just a penny. So on the t-shirts, I'm over by 3 cents. So I only overestimated by 5 cents in the whole total bill. So my estimated answer of 130 is very, very close to what the actual pair is. So 5 cents less than 130, I'm still at $129.95. So seeing that, I know now that I am over the $100. So therefore, the answer that we want to talk about again is, let's go back to the question, does he have enough money? And so the answer would be no, he does not. So that would be one thing I would need to write down. And then all of the work that I've done here is my rationale, my way to explain why he doesn't have enough. So you need to show your work along with the no to get full credit on a particular assignment. So hopefully you came up with no, and hopefully you came up with using some simple math. You could have done the problem to exact by just multiplying 34.99 times 2 and 19.99 times 3 and adding that all up. But notice by overestimating just a little bit, I made the math a lot easier to do. I understood that I overestimated a little bit, and I can still come up with the correct answer.